All right, so suppose we have two operators A and B from B to W and W to U. If these are bases for U, W, and U respectively, then for matrix representations, we have this. We would like to see how tensor representations of ABC are related, how they are related. And to see that, okay. Okay. So let A, for example, be this gadget. So let head be okay. Yani aslında ahead diye ki şöyle bir şey. Summation over K. I don't need to use basis vectors, but yeah, okay. And suppose this is just W K B K. No, FK star. FK star. And B hat is a map from W to U, so it's another summation over L. Let's say UL tensor GL star. Here WKs are in W, FK star in B star, ULs are in U, and GL star are in W star. Evet. Çünkü bu nerede? This is in W tensor B star, and this is in U tensor W. Okay. Well, then what will be the composition? So B hat composition, C hat. B hat composition, A hat is what? Well, B hat is just this gadget, summation over L, L, tensor VL star, and you compose this by a hat WK tensor FK star. Şimdi bakın, when you feed this guy with a vector B, so when you put a B here, what you do, you put B here, and FK star will eat B, and it will go out as a scalar. And you can take scalar outside, and then you will be left with the vectors WK. And this WK is in W, and this is the dual element. So this guy will eat WKs. This gadget will will stay as a scalar, and this will be the vector left, and this guy will eat that vector. Okay, so this guy will eat this vector, and then you will get this gadget. So what will happen when G L star is this guy, you will get a scalar of this type. G L star W K, and you will be left with a vector here, and you have also this gadget here, and this is summation over. I have two summations, both L and K. So the composition as a tensor can be written like this. Where is this gadget? This is in U, and this is in this type. And that's the right place, right? U tensor is star composition. Geçişi anladınız mı? Yani buraya, so if I want to know what this gadget does for a vector D, I will put it here, and D will be eaten by this guy. Then this guy eats D, you will get a scalar, and you can take the scalar up here. You will be left with the vector WK. And WK will be eaten by this corrector. So you will get another scalar that will go out, and you will be left with this vector. So you have this vector. This guy will eat this guy, you get this scalar, and then you have FK star. So when you feed this guy with B, you just write B here, and you are done. Yani yaptığımız şey nedir? Bunları yan yana koyuyoruz. Kim kimi yiyorsa yiyecek. Değil mi? Bu W'da vektör, bu W'daki vektörleri yiyen nesne. O zaman onu yiyecek. Bir skaler çıkacak. O skaleri de dışarı atıyoruz. Geriye ne kaldı? Bu ve bu. Onu da tensör diye yazıyoruz. So this is the result. Bu tensör notasyonunun güzelliği o. Yani işte ne yiyorsa onları yediriyorsunuz. Geriye ne kalıyorsa onlar kalıyor. Mesela bir örnek yapalım. Okay, let's see one example. Let's say A is a map from R2 to R3 and we have the vector from so linear map from R önce A ile sonra B ile gidiyoruz. Yok, evet, tamam. Bu 3-1'dan nereye gidiyoruz? Diyelim ki bu da 2-1'a gitsin. So composition C B hat composition A hat will go from 2-1 to 2. Peki, mesela standart bazları kullanayım. A hat'in matrix representation'ı şu olsun. I will not write as matrix representation. I take standard basis for R2 and R3, which are 1, 0, 0, 1, 1, 0, 0, and so on. Standard basis. And suppose the matrix representation is given by, so let's say -1, 4, 7, 0, and 3, -2. Okay. A hat is this. Evet. B hat it's a so okay 2, 3, 5 -1 6 and 0. Suppose It is this one. All right. So C hat is then what? It is just 1 minus 1, 4, 7, 0, minus 3 minus 2, and then you have 2, 3, 5, minus 1, 6, 0. So this is a 2 by 2. Evet, önce A sonra B değil mi? Zaten bu 3'e 3 çıktı. Biraz sıkıntılı. İki, üç, beş, eksi 1, 6, 0, eksi 1, 4, 7, 0, eksi 2, 21, 15 daha, 21, 15 daha, 36, 2 çıktı, 34. Tamam. 34. 8, 0, eksi 10, eksi 2, 1, 42, 43, eksi 4, 0, 0. So it is this one. Tamam mı? Now let's write down A hat and B hat in what form? Tensor form. Okay. So A hat can be written like this. I have two vectors. For each vector, I know what the result is. Yani şöyle diyeyim. A hat bir sıfır koyduğumuzda so E1, this is E1. What is the result? For yok. 1, 7, 3 değil mi? 1, 7, 3. Eksi 1 olur. So this is what? I can write this as follows. Minus 1, 7, 3, answer E1 star, right? This guy eats E1 and gives me this gadget. Plus, what about 0, 1? Well, okay. 4, 0, 2. Değil mi? Eksi 2, evet. Sıkılmam. 4, 0, minus 2, 3, 2, star. Right? Ahead is this. Okay. What is singing? Now let's write down B hat. Kim o tahtayı? Okay, buldum. Yerlerini değiştirmiş de. Neyse ki sonundan seçenek var. Okay, so let's write down also B hat. Şimdi A hat'i B hat'e yedireceğiz. Evet. Tamam. Let's write down B hat. B hat on the vector 1, 0, 0. The first vector. What is the result? B hat neydi? 2, 3, 5. 2, 3, 5. Eksi 1. 6. So 1, 0, 0. 2 minus 1, right? It gives us 2 minus 1. So this is just what? Bu vektör yiyince bize bunu veriyor. Efendim? Evet. Şimdi bunu da tensör gibi yazacağım. Ama o tensör sonra bunu yiyecek. Bunu yerken şimdi şöyle şöyle yazabilirim. Yani orada sorun olmayacak. Bunu yiyince bunu veriyor. Yani 1, 0, 0 tensor yok. Pardon. 2, 1 tensor 1, 0, 0. Tamam. Evet. Bunu yiyince plus 0, 1, 0. Bu ne verecek? 3'e 6. Yani 3, 6 tensor 1, 0, no, 0, 1, 0 star plus 5, 0, 0, 0, 0, 1 tensor. Okay. Now let's see what is A hat, B hat. Composition. Önce A hat, sonra B hat. B hat composition. Okay. B hat bu. İsterseniz bunu şöyle de yazabilirim. Orada direkt evet. Şöyle de yazabilirim şimdi. 2, eksi 1 tensör 1, 0, 0 star plus 3, 6 değil mi? Tensör 0, 1 star plus 5, 0 and then 0, 0, 1 star. This is applied to what? Minus 1, 7, 3 E1 star. Evet. 4, 0 minus 2 E2 star. Okay. Şimdi ne yapacağız? Her birisi yiyecek. So, this guy I take this guy with this one. How? You see, this is dual element, it will eat this vector. Bu hangisini ne verir bana? Bu birinci vektörün duvarı, değil mi? O halde ilk entry verecek. So when this guy eats this guy, it will give me what? Minus 1, right? Yani şöyle düşün, bu F1 dual, F2 dual, F3 dual. F1'i şöyle yazarsan, hani F1 1, 0, 0, F2 0, 0, 0, 1, 0, F3'te işte 0, 0, 1. Bu F1'in duvarı, F2'nin duvarı, F3 So this is F1 due, F2 due, F3 due. F1 due, it's this guy. This guy is minus 1 F1, 7 F2, 3 F3. Right? This guy is just minus 1 F1, 7 F2, and 7 F2 and 3 F3. And this is F1 due. F1 due, if this guy will give me 1. F1 due, if this guy will give me 0. F1 due, if this guy and give me 0. So this guy will just give me this element. Okay, so what is the result? Then, yani bunu yiyecek, bana eksi 1 verecek. Eksi 1 verecek, eksi 1. Ondan sonra geri kalanları yazıyorum. 2 eksi 1. Tensor eksi star. Plus. Bunu yiyecek. Bunu yiyince ne verir bana? İlk entrisini veriyor, değil mi? So this is 4 times 2 minus 1 tensor into star plus okay, o kadar. Ondan sonra this side will give me something. So plus now this guy will eat this one. It will give me the second entry, which is 7. 7 times 3, 6 tensor E1 star plus this guy will eat this guy. It will give me 0 because second entry here is 0. So it doesn't give us anything. I can just skip that. And then here the third vector, it will eat this guy and it will give me 3, 3, 5, 0. And then cancel E1 star plus it will eat this guy. It will give me minus 2, 5, 0, and into star. So what is the result then? So we have composition effect is what? E1 star, I have two. Yok, kaç tane terimim var? 3 tane var, değil mi? E1 star'lı. What are the coefficients? Yani buradan eksi 2'ye 1. Sonra so E1 star parenthesis, I have this vector plus this vector, which is 21 plus 42 plus 15 and 0. So this vector tensor E1 plus E2 star'ın katsayılarını ve coefficient of E2 star 8 minus 4 no E2 star, no E2 star, and here I have minus 10 0 E2 star. So what is this one? 36, 34. Buradan da 43 mü? İran star var. Eksi 2 ve eksi 4. Burada aralarında artı var. Yani bunlar matris değil mi? Evet. Well, you see, it is this matrix. Looks good. Oh. So you get the Onun kaçıncı tahtaydı o? Allah bilir. Yok, nasıl değil? Okay, so you get this matrix. 34, 43 minus 2, and minus 4. Yes. Tamam mı? Sorusu olan var mı? Evet. Kim neyi yiyorsa onu yiyecek. Geriye işte ne çıkıyorsa o kalacak. Bitti bu. Okay. Okay. So let's, for example, do şey yapsam olur diye düşünüyorum da. İki tane reflection'ın kompozisyonu rotation'dır. Değil mi? So if you have two reflections in the plane, neyse onu ben sonra düşünürüm. Şimdi evet yazarsam eminim karıştıracağım. Şey yapabiliriz. So whenever you have two reflections, their composition is always a rotation. Okay? And we can see that fact using this tensor representations, but one has to be careful. So I don't want to now do it on the board. Let's do it later. Next time I'll prepare it. Okay. Here is another definition. The rank of a linear map ahead from B to W is the dimension of the image subspace which we denote by image ahead in W. Okay. So what is the rank? You look at the image of this linear operator. We know that it is a subspace in W, but subspace is another vector space, and we would like to know what's the dimension of this vector space. That is the rank of A hat. So rank of A hat is just dimension of the image subspace. Tamam mı? Let's do one example. Let's say A hat is a map, linear map from R Q1 into R Q1, and suppose it is given by this rule. So Okay. Okay, it is given by this. Okay. 3, 0, minus 1, 1 star plus. Okay, so it's given like this. What is the image of this? Okay. Efendim? Evet, bakalım. Yani imajını bulmak için ne yapacağım? So, just you look at the image of this on any vector, right? So, if I choose a vector in R2, cross 1, then it is something like this. It is just C1 times E1 plus C2 times E2, right? E1 being this vector, let's say 1, 0, and E2 is this vector 0, 1. Okay, 0, 1. Oh, come on. So let's just compute the image. So a head of V is what? Anything in the image has this form. A head of C1 E1 plus C2 E2. But a head is just this operator, this linear map, sorry. So this is applied to this header. So 3, 0, minus 1. E head is will eat this guy, it will give me what? Just C1. And E star will eat this guy and give me just 0 because E1 star evaluates at 0 here. So you just get C1 times 3, 0, minus 1. So what we see is that anything in the image is just a multiple of this vector. So image is one-dimensional, right? Any image vector is a multiple of this vector. So in of A is just the set T times, let's say, 3, 0, minus 1. Right? C is a real number. And we can write this way. So it is the gadgets spanned by this. So this means it is the subspace spanned by this vector. Okay, just multiples of this. Yok, matrisin dimension'ı değil. Bu subspace'in dimension'ına bakıyorum. Şimdi subspace nedir? Subspace bir vektör uzayı ve buradaki her vektör 3, 0, eksi 1'in katı. Her vektör bunun katı. O zaman bunun için bir baz yazmak istersen ne yazarsın? 3, 0, eksi 1 değil mi? Bunun bazı. Çünkü her vektör bunun katı. O yüzden bunu ifade etmenin yolu da bu. Hani eğer vektör uzayınızın bazı diyelim ki E1, En ise onu şöyle yazıyoruz. Hani E1'den E'ye kadar bunu span ediyor. Burada tek bir vektör var. So what is the dimension of this subspace? Well, everything is a multiple of this vector. So one vector spans everything. Therefore, dimension of image A is just 1, right? The observation is the following. My operator here, A hat, given in this tensor form, has only one term, right? One term. I don't have a summation. I don't have two terms, just a single term. And in that case, the rank became 1. So I have one term here and the rank is 1. And that's not a coincidence. That's the theorem. So it is the next result. A linear operator may have several representations as tensors, but among them there are some that contains minimal number of terms, and that minimal number is nothing but the rank of the linear operator, linear number. So that's the theorem. So let me just write down the theorem. Okay. Theorem is this. The rank of a head is the smallest integer means the number of terms necessary to write an operator A hat into W as a sum of single term tensor products. In other words, the operator and head can be expressed as şöyle yazılabilir. And head, so from 1 up to the rank of the head, okay, the WK and FK star as an element of the tensor product W is star, right? An operator from V to W is a tensor in W tensor V star. And if the rank of this, let's say 5, then you can write this as a sum like this with only 5 terms. And you cannot write it as a sum of 4 terms. So 5 is the smallest number required to write this as a tensor. Of course, you can add other terms. You can obtain representations with more terms, but you cannot get a representation with fewer terms. Yani round base'le siz bu operatörü 5 tane terimli bir toplam olarak yazabilirsiniz. 6-7 de yazarsınız. Nasıl yazarsınız? Yani bunu 2 kere yazarsınız. Değil mi? Yani 1/2 yazarsınız, 2 defa yazarsınız. Ama daha az sayıda yazamazsınız. Tamam mı? So rank appears in this tensor representation. And the proof of that is actually simple. This gives an idea, actually, right? Here I have only one tensor, and we see that the image is just a multiple of this vector. Therefore, image is one-dimensional also. And that's the key idea, actually. Pek de zaman kalmamış. Okay, let me stop here. So next time I'll remind you what we were doing, and then we will prove this. Yes. We have, I'll follow the book, tensor products and then wedge products, and then we will test two determinants. I will skip some of them. But I mean,
arkadaşlar bakar mısınız? Temsilci seçimleri oluyor da bu temsilciliklerin ikinci sınıfların idaresini temsil edilmesi için mümkün olduğu kadar fazla oy katılımı önemli. Oylarımızı kullanalım. Sorunuz varsa dışarıdayız bunun hakkında. Yani oyları kullanalım yani. Kullanırsak iyi olur.
ya belki o şeylerin bir kısmını atlayacağım. Sonradan belki döneriz onlara. Hani böyle çok fazla da işi notasyona böyle indekse falan boğmak istemiyorum. Determinantları da yapmamız lazım. Onlara da biraz zaman ayıracağız. O da işte bu wedge'lerle alakalı. Tensörlerin devamı olarak determinantlara geçeceğiz. Evet. Ben şöyle şimdi bunun yenmesine kadar eğer kaynaklardan bu yeni yen ne diye şu ben bu mesele baktım ben bunu
olduğunu sanmıyorum lan nedense.
Kaybolmuştur.
Evet.
Ya ben bunu şöyle yazdım.
Ben bir şey gördüm demiştim. Neydi o? Arkadaş sorunca test sonra